Bismillahirrahmanirrahim. Assalamu alaikum students. Hope you all are fine. I'm Mrs. Nadia Rao from Department of Chemistry, Army Burnhall College for Girls, Ahmedabad. Girls, you have been attending your online lectures that are being uploaded on your portal. I hope you are taking all the benefit from the knowledge that is being communicated to you. Today we are starting with the second chapter of organic chemistry. It is in fact chapter number 16 in your books, that is hydrocarbons. In this lecture today, we are going to study about some starting topics of this chapter, that is introduction of hydrocarbons, types of hydrocarbons, and among alkanes, we are going to discuss nomenclature of alkanes only. By the end of this lecture, you should be able to classify hydrocarbons as aliphatic or aromatic, as you have studied about the types of hydrocarbons. You should be able to name various alkanes, and you should be able to draw structures of various alkanes as well. Starting with the hydrocarbons. As the name is indicating, the term hydro stands for hydrogen and carbons stand for carbon only. So these are those organic compounds that consist of carbon and hydrogen as their major elements only. They don't have anything else in them like oxygen, sulfur. You might have studied about some of the organic compounds that do contain other elements as well. But hydrocarbons are those class in which there is no other element except hydrogen and carbon. Hydrocarbons comes in variety of forms. There may be gases, they may be liquids, they may be waxes, or they may be polymers. Among gases, you are familiar with the methane and propane gas. You are familiar as a liquid, hexane and benzene, etc. These are liquids. Waxes contain some naphthalene, paraffin wax, and polymers contains polyethylene, polypropylene, polystyrene, etc. Do remember, hydrocarbons show a very important property of catenation. And what is catenation? Catenation is self-linkage of carbon with each other. Carbon can link itself with more carbon atoms to form long chain kind of structures. This is a tree chart, or this is on the basis of structure. Hydrocarbons are divided into two main classes, that is open chain compounds and closed chain compounds. As the name is indicating, open chain compounds means these will be a straight chain compounds that are having longer chains, and closed chain compounds will be those compounds that will be in the form of a cycle or a ring. Open chain compounds are further divided into two classes, that is saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons include alkanes and unsaturated hydrocarbons includes alkenes and alkynes. Among closed chain hydrocarbons, there are two types. They can be homocyclic or they can be heterocyclic. As I told you, closed chain compounds are those compounds which are in the form of a cycle or a ring. The term homocyclic means homo stands for same, cyclic for the ring. Homocyclic compounds are those compounds in which ring is having carbon and hydrogen only, the same elements. Heterocyclic will be those compounds that may be having some other elements other than carbon and hydrogen. But usually we are not going to study them in this chapter today. Homocyclic compounds are important to us. They may be of two types. They can be either aromatic or they can be alicyclic. Now we are going to discuss details of all these types of hydrocarbons. First comes open chain hydrocarbons. I told you already, open chain hydrocarbons are of two types. They can be saturated hydrocarbons or they can be unsaturated hydrocarbons. Open chain hydrocarbons are also called as acyclic hydrocarbon. The term acyclic, A stands for absence, cyclic for cycle. Open chain means they don't have any cycle, they don't have any ring. These are straight chain hydrocarbons. Saturated hydrocarbons are those hydrocarbons in which carbon and carbon atom are linked together through single bonds only. They have all sigma bonds. These are usually alkanes, and the common name for alkanes is paraffins as well. Why these are called paraffins? The term paraffin means little affinity. They have little affinity or little attraction or less attraction for the other compounds. Means they are usually inert or they react very less with some other compounds. That's why these are called as saturated hydrocarbons as well. Why these are saturated? Saturated means all of the carbon and hydrogen bonds are completely saturated. They don't need to combine with anything else. Their bonds cannot be broken up. They cannot add anything else into them. Do remember, these are all single bond compounds, so of course hybridization in them will be sp3 hybridized. All of the carbon atoms will be sp3 hybridized. Examples are, we can have example of methane, ethane, a 2-carbon compound, propane, a 3-carbon compound, and butane, a 4-carbon compound. As you can see, in all of them, carbon atoms are linked with carbon atoms and with the hydrogens through single bonds only. And hybridization of carbon, when it is attached with 4 single bonds with something else, the hybridization is sp3 hybridization. In case of unsaturated hydrocarbons are those hydrocarbons which have either a double bond or a triple bond between 2 carbon atoms. The compounds which have double bond between 2 carbon atoms are called as olefins, oil-like. These are having carbon atoms which are sp2 hybridized. Not all of the carbon atoms will be sp2 hybridized, but the 2 carbons which are holding a double bond or a triple bond, these 2 carbon atoms will be sp2 hybridized or sp hybridized. In case of triple bond compounds, these are also called as acetylenes. They have common name. This is the common name of triple bond compounds. Acetylenes or alkynes as well. These are having a triple bond between any of the 2 carbon atoms, and these 2 carbon atoms which are holding a triple bond would be sp hybridized. You can see example of 1 pentene is being given to you, example of 2 pentene is being given to you, and here we have 1 butane and 2 butane. This is the class called alkynes, right? In the next slide, I am showing you some compounds or some categories or some, you can say, in this slide, various structures of pentanes are being shown to you. Pentane is a 5-carbon compound. When pentane is having all single bonds between carbon atoms and hydrogens, it is called pentane, and it is a alkane, which is a saturated hydrocarbon. If there is a double bond present between any of the 2 carbon atoms, it would be called pentane, which comes in the class of unsaturated hydrocarbons called alkenes. And in the same way, if there is a triple bond between any of the 2 carbon atoms in this chain, it would be called a pentyne, and this is the class of compound called again unsaturated hydrocarbon, and this class is alkynes. This circle is indicating the double and triple bonds, and similarly another compound, that is benzene, which are usually called arenes as well. This is also an unsaturated hydrocarbon that is having 3 double bonds and 3 single bonds that are in alternate positions to each other. The next class of hydrocarbons is closed chain hydrocarbons or cyclic hydrocarbons, in which these closed chain hydrocarbons or cyclic hydrocarbons are of further 2 types: alicyclic hydrocarbons and aromatic hydrocarbons. Girls, do not get confused with acyclic and alicyclic hydrocarbons. Acyclic means absence of the cycle or the ring. This alicyclic hydrocarbon means Ali stands for aliphatic and cyclic for cyclic hydrocarbons. Aliphatic hydrocarbons which are in the cyclic form. Aliphatic means non-aromatic hydrocarbons, we would say. They have 2 hydrogens less than the open chain hydrocarbons. Whatsoever is the number of carbon atoms and hydrogen atoms in the open chain structure, 2 of the hydrogens from that structure become less, and they come in the form of a cyclic structure. They can have single bond, they can have double or triple bond with them. For example, the first one is cyclopropane. Propane stands for 3-carbon compound. These are 3 carbons which are linked, you can see, in the form of a cycle or a ring. It can be represented in this way, or it can be represented by a simple triangle. Every corner is showing a carbon atom, and rest of the tetravalency of carbon atom will have to be satisfied. Similarly, you can have a cyclohexane. Hexane is a 6-carbon compound. When I write the term cyclo with it, it means it is in the form of a ring or a cycle. Each carbon atom, this is represented in the form of a hexagon. Each corner is representing a carbon atom. So there are 6 corners. We can say this is a 6-carbon compound or cyclohexane. Aromatic hydrocarbons, as the name is indicating, and you might know as well, these can be benzene containing compounds. The name aromatic comes from aroma. Benzene containing compounds originally were having some aroma or the fragrance. That's why these were named as aromatic hydrocarbons. Aromatic compounds, the hydrocarbons that are having benzenoid cyclic structure in them are called aromatic hydrocarbons. They have single or double bonds in them. They have alternate single and double bonds in them. The benzene structure is must for these kind of compounds. All of the carbon atoms are sp2 hybridized. I'm talking about all of the carbon atoms, not any two. All of the 6 carbon atoms in this benzene will have sp2 hybridization. Similarly, derivatives of benzene, like the compounds which can be derived from benzene, but they have the basic core structure of benzene in them, are also included in this type. For example, toluene, it is having a methyl group attached at benzene ring. Similarly, when 2 benzene rings combine together, they make naphthalene, so it is also included in aromatic hydrocarbons. I hope you have understood well about various types of hydrocarbons. Now comes a quick quiz which is given in your books, and it includes some short questions, that is, what is catenation, what are hydrocarbons, why saturated hydrocarbons are called paraffins, why unsaturated hydrocarbons are called olefins, what is hybridization, why benzene is called aromatic hydrocarbon, and what is a hexagonal structure. You can find the answer of all these questions from this lecture. Go through lecture again and again. You would get to know about the answers. These are short answers which should be comprising of 3 to 5 lines only, and you have to do it by yourself. Now moving on towards the next topic, which is very important. It is called nomenclature of alkanes. This is a very important topic, girls, because I would say it is in fact the key of organic chemistry. You cannot master organic chemistry unless and until you know about nomenclature. What is nomenclature? Nomenclature means naming alkenes. Why we have to name them? Because with the increasingly large number of organic compounds that are being identified with each passing day, together with the fact that many of these compounds are isomers of the other compounds, require that a systematic nomenclature must be developed. Just as each distinct compound has a unique molecular structure which can be designated by a structural formula, each compound must be given a characteristic and unique name as well. As organic chemistry grew and developed, many compounds were given the trivial names. Trivial names means the old names or the common names, which are now commonly being utilized and recognized as well. For example, methane, toluene, acetone, etc. Such common names have their origin in the history of science and the natural sources of specific compounds as well, but the relationship of these names to each other is not clear, and no rational or systematic principle governs such names. So that's why in 1892, as number of known molecules grew, chemists decided that they should develop a systematic naming system, which was devised by IUPAC. IUPAC is International Union of Pure and Applied Chemistry. They have invented a system of naming various compounds, organic compounds, and instead of learning common names for every molecule, we should learn IUPAC system. We should know what is IUPAC system so that we can name various compounds. There are some important general facts about alkanes that you should know. You have studied about it in the previous lecture as well, but let me remind you once again. The formulas and structures of these alkanes increase uniformly, as you know, by just a small molecule, which is CH2 molecule. This uniform variation is usually called homologous series. You are familiar with the various homologous series as well. All of these fit in the formula, all of these alkanes fit in the formula CnH2n. They follow this rule, CnH2n plus 2 rule. For example, any alkane with 8 carbon atoms will have molecular formula N will be 8 now because it is having 8 carbon atoms. So number of carbon atoms is 8 and number of hydrogen atom will become double to that, added 2 into it. So it will be C8H18. And name of all of the alkanes, do remember, they will always end up with the suffix "ane". The term "ane" comes with the alkane. So whatsoever is the name of the compound, if it is ending up with the term "ane", that means it is a alkane. It is a singly bonded compound. Before moving on towards IUPAC system for nomenclature, we should be able to know about alkyl groups first. What is alkyl group? Alkane, we know it is a organic compound, but what is alkyl? Alkyl is a substituent which is usually derived from alkane, and as the name of alkane ends up with the term "ane", we will have to replace alkyl group with "ane" will be replaced by "-yle". For example, if we have a methane CH4 and we remove one hydrogen from it so that it can be attached to anything else, it won't remain methane but it would become alkyl group, that is methyl group. Instead of methane, the last term "ane" is being replaced by "-yle" and it is called a group. It is a substituent group. Substituent means that has to be attached with something else. Similarly, ethyl group. Ethyl is derived from ethane, CH3. CH3 is ethane. If we remove one hydrogen from one of the end and we attach this group with something else, it would become ethyl group. Similarly, we can have propyl group from propane. We can have isopropyl if it is branched. And do remember, propyl group is the one in which the terminal carbon atom is attached with something else. But if middle carbon atom is attached with something else, as the red line is indicating the point of attachment, it should be called isopropyl group, not propyl group. Similarly, we can have butyl group derived from butane. Butane is C4, having 4 carbon atoms and there are 10 hydrogen atoms. Out of that, if we remove one hydrogen from the terminal end, it would become butyl group. And if it is attached from the middle carbon atom with anything else, as the point of attachment this red line is showing, it would become secondary butyl group or isobutyl as well. S stands for secondary butyl. Similarly, and if a branched butyl group is being attached through terminal end with the any chain, it is called isobutyl group. Similarly, we can have a tertiary butyl group as well, in which central carbon, which is highly branched, is attached with the major chain. It is called tertiary butyl group. Here I am going to show you a table of homologous series, and we are going to derive later on from this homologous series. We are going to derive the alkyl groups. For example, when there is one carbon atom, you know it is called methane. When 2 carbon atoms are there, it is called ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane for 10 carbon compounds. If we are going to make them alkyl groups, we will have to keep the root name the way it is. For example, when we have one carbon, it is called methane. We are removing the term ane and we are replacing it by the word bile to make it a methyl. So root name would remain the same, it is meth. When there are two carbon atoms, it is called eth, and when it is an alkane, it is called full ethane. But when it is a alkyl group, alkyl substituent, it is called ethyl. Similarly, three carbon atom compounds, that is prop, would become propane if it is a full alkane, and if it is attached with something else as a substituent, it would be propyl. Similarly, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl groups can be there. The symbol capital R is used to designate a generic or unspecific alkyl group. For example, ethyl, methyl, collectively these will be included in alkyl groups, and that will be represented by the symbol R. There can be some other substituent as well. There can be halogen substituents. For example, fluorine, chlorine, bromine, iodine, etc. They can be attached with the parent chain as well. They would be named by the term O will be added up in the end. For example, fluorine would become fluoro if it is attached with the major chain. Chlorine would become chloro, bromine would become bromo, and iodine would become iodo in that case. Now moving on towards the IUPAC rules for nomenclature of alkanes. Now we will follow, there are some set rules for the nomenclature that we have to follow. A rational nomenclature system should at least do two things. First, it should indicate how carbon atoms of the given compound are bonded together in a characteristic lattice of chains and rings. Secondly, it should identify and locate any functional groups that are present in the compound. Since hydrogen is a common component of organic compounds, its amount and location can be assumed from the tetravalency of carbon and need not to be specified in most of the cases. The IUPAC nomenclature system is a set of logical rules devised and used by organic chemists to overcome problems caused by the simple nomenclature systems. Knowing these rules and given a structural formula, one should be able to write a unique name of every distinct compound. Likewise, given a IUPAC name, one should be able to write a structural formula as well. In general, an IUPAC name will have three essential features. It should have a root or base, indicating a major chain or ring of carbon atoms found in the molecular structure. It should have a suffix or other elements designating functional groups that may be present in the compound. And it should have the names of substituent groups as well, other than hydrogen, that complete the molecular structure. Hydrogens need not to be mentioned in the name because it is understood that the tetravalency has to be satisfied. As an introduction to IUPAC nomenclature, we shall first consider compounds that have no specific functional groups. Such compounds are composed only of carbon and hydrogen atoms bonded together by the sigma bonds. And do remember, all of the carbon atoms are sp3 hybridized. There are some set rules for the nomenclature that are being discussed over here along with various examples as well. You will have to note all these examples in your notebooks. Okay. Rule number 1. Select the longest continuous carbon chain in the compound that is being given to you and count the number of carbon atoms present in it. The chain can be straight chain, it can be a coiled one as well. It will not always be a straight chain. It can have many coilings as well. You will have to choose the continuous carbon chain that should have maximum number of carbon atoms in it. For example, you can see this compound. It has got two chains of the carbon atoms that are linked together by one intermediate carbon atom. These two chains can have two kind of numberings. First one is being shown to you people over here. You can see if I follow this highlighted area, How many carbon atoms will come in a continuous chain? Let's count 1, 2, 3, 4, 5, 6, 7 and 8. If I count the number of carbon atoms in the straight chain above, these will be 1, 2, 3, 4, 5 and 6 only. So this chain should be preferred which is having more carbon atoms, that is 8 carbon atoms. But that is even not correct. Why? Because there is another continuous chain that can have more carbons than this chain. For example, as the highlighted area is being shown to you people, can you see this highlighted area? And can you count number of carbon atoms present in this highlighted area? That is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this chain is having 9 carbon atoms. The straight chain was having only 6 carbon atoms and this chain was having 8 carbon atoms. So these two numberings are not correct. The one in which straight chain is counted or this one is being counted. This numbering is not correct. This is the correct numbering where maximum number of carbon atoms, that is 9 carbon atoms, are included over here in this chain. Now these two carbon atoms will be considered as substituents. So the first thing that you have to do while naming an organic compound is you have to select the longest continuous carbon chain and count the number of carbon atoms present in it. After doing that, the second rule you have to follow. What is the second rule? You have to number the chain so that the substituent gets the lowest possible number. You have to give numbers to these carbon atoms. For example, you can see here substituent is ethyl group, which hangs on the parent hydrocarbon. This is the black area. This is the parent hydrocarbon. We need to number the carbons of the parent chain so that substituent should get the lowest number. So in this case, if I start numbering from this point, that is this carbon is numbered 1, this is 2, this is 3, 4, 5, 6, 7 and 8 and 9. You can see at carbon number 6 there is a substituent which is called ethyl group. It has got 2 carbon atoms in it. But if I start numbering from this side, that is this carbon is numbered 1, 2, 3, 4, 5, 6, 7, 8 and 9. In this case, the substituent is attached at position number 4, at 4th carbon atom. So we should always follow the numbering which should give lowest number to the substituent that is being attached. So this will be the correct numbering that you have followed. So what you have to do, first of all you have to choose the longest continuous chain. Then you have to number the carbon atoms so that the substituent should get the lowest number. Once you have understood these two rules, you can name the compound very easily. Do remember, as per IUPAC rules, the name of alkyl group and the parent hydrocarbon are to be written in continuation and hyphen is used between the number and the alkyl group. Now, if we want to write the name of this substituted alkane, first of all, you have to see that parent chain is having 9 carbon atoms, right? Parent chain is 9 carbons long, so the name of the parent hydrocarbon would be nonane. And substituted alkyl group is ethyl group, which is attached at position number 4 to the parent hydrocarbon. So name of the compound, what you have to do, you have to first of all mention the position of substituent, that is 4. Then write the name of substituent, which is ethyl, and in the end write the name of the parent compound, which is nonane. We are going to practice a lot many compounds later on as well. Now the third rule of nomenclature is, if a compound has 2 similar length parent chains, then which parent chain should be chosen? we are going to choose the chain which has the greatest number of substituents attached to it. For example, two examples are being shown to you again. One of the chain is having, you can see in the first example, the one of the chain is having 7 carbon atoms. But if we choose another chain, in this you can see 1, 2, 3, 4, 5, 6 and 7. Upon position number 3, there is alkyl group attached which is called isopropyl. So this compound can be named as 3-isopropyl heptane. 3 is the position of isopropyl group. I told you what is isopropyl. Isopropyl stands for branched propyl group, in which 3 carbon chain is linked through central carbon with the parent chain, and name of the compound is heptane. But this name is incorrect. Why this name is incorrect? If I start numbering from this point instead, like from this point instead, these are the two same compounds. If this carbon is numbered 1, 2, 3, 4, 5, 6, 7, even then number of carbon atoms is same, it is 7. But the second chain is the correct one. Why? Because it has got two substituents. One is attached at position number 2 and another one is attached at position number 3. This group will now not be considered in the parent chain, but it will be considered as a substituent over here now. So the name of this compound would be now 3-ethyl. Upon position number 3, there is ethyl group attached, and then there is 2-methyl. Upon position number 2, there is methyl group attached, and the parent compound is heptane. Rule number 4 is regarding the number of substituents. If there is more than one substituent present, then we have to assign numbers in a way that will result in the lowest possible numbers coming in the name of compound. While writing the name of compound, we have to arrange all of the substituents in the alphabetical order. You can understand this with the help of an example. Let's try to name this compound. You can see a simple straight chain is being shown to you that has got 10 carbon atoms in it. So the name of compound is of course a decane having 10 carbon atoms. You can see there are two substituents that are being attached. One of them is methyl, another substituent is ethyl group. If we number the parent chain in this way, so that this is first carbon, this is second carbon, this is third carbon, fourth, fifth, sixth, 7th, 8th, 9th and 10th carbon atom is present here. We can see attachments are present at position number 3 and 6. But if I try to number it in the alternate way, in the opposite way, like if I start from here, this carbon is carbon number 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. Both of them are the same compounds. But now if I number it in the opposite direction, we see that ethyl group and methyl group are getting numbers 5 and 8. 5 and 8 both are higher numbers as compared to 3 and 6. So we will have to choose the naming or the numbering in which lowest number should be given to all of the substituents. So the correct name is the one in which this numbering will be followed from this side towards this side. So it will be 6-ethyl 3-methyl decane, and the name 5-ethyl 8-methyl decane, that is 5-ethyl 8-methyl decane, is incorrect. Girls, do remember we have to name the substituents in the alphabetical order, no matter what is the number of the substituent that is coming in the chain. For example, you can see this is 6-ethyl. Why we are not writing it later on, and why we are not writing this methyl first? Because E is alphabetically coming first and M comes later on. So that's why it will be 6-ethyl no matter what is the number of this ethyl group. If it is higher, doesn't matter. You have to name it first with the one which is coming alphabetically first. Now rule number 5 is related to multiple substituents if they are present. Girl substituents are sometimes called locant as well. So this rule is related to multiple substituents if they are present in the parent carbon atom. For example, you can see this carbon chain, which is 5-carbon chain, but it is having multiple substituents. On position 2 there are 2 methyl groups, on position 3 there is a methyl group, and on position 4 there is a methyl group. From both of the sides, the first substituent is getting number 2. If I number it from this side, even then this carbon is getting number 2 and it is having a substituent. So if we follow this kind of numbering, the substituents are getting, this methyl group is getting number 2, this methyl group is also getting number 2, this methyl group is at position number 3, and this methyl group is at position number 4. So you will have to take sum of the substituents. This is called sum of the substituent rule as well. You will have to take sum of all of the numbers that substituents are having. So this sum will give you 11. But if I number it otherwise, if I number it in the backward or in the opposite direction, I would have 2 over here, I would have 3, I would have 4 as a substituent. Upon 4 position again I am going to have a substituent. So overall sum of all of the substituents will give you 13. So you will have to choose the numbering which is giving lowest sum of locants. So this is giving the highest sum, this numbering will be wrong. Instead you are going to follow this numbering which is giving lowest sum of the locants or lowest sum of the substituents. Here are some special cases as well that we need to discuss over here. If there is a same substituent attached to the parent hydrocarbon at different positions, as we have seen in the previous example as well, there were 4 methyl groups that were attached at different positions in the compound. You could see there are 4 methyl groups present. So in that case, how you have to name it? Then we have to use the term di for 2 same alkyl groups if they are attached. If there are 3 same alkyl groups, we are going to use the term tri, tetra and penta for corresponding repetition of 2, 3, 4 and 5, etc. And we are going to write their numbers in the ascending order, for example, which will be separated by commas. For example, you can see this example. It is a normal heptane having 7 carbon atoms in it, and it has got 2 methyl groups attached at position number 2 and 6. So instead of writing again and again 2 methyl and 6 methyl, we are going to combine these two as dimethyl. And we have to specify their positions. Positions are 2 and 6. These are mentioned that wherever they are located. So it will be upon position 3, it is ethyl group which is present over here. Position 3, ethyl is being mentioned first because E comes in the alphabetical order, E comes first. So 3 ethyl, and it is 2,6 dimethyl heptane, right? Instead of that, if you write, and of course the second structure, the second name is wrong, in which opposite direction, the numbering is starting from the opposite direction, where we are having attachments of methyl group at position 2 and 6, which is same as this one. But ethyl group, if we number it in this way, ethyl group is going to get number 5. So you can now apply rule of sum or sum of locant rule as well, sum of substituent rule here, and you would see if you try to add these numbers, that is the number of substituents 2, 6 and 3, it will give sum of 11. And if you are going to add 6, 2 and 5, it is going to give you the sum of 13. So this numbering will not be followed. You may notice in the above mentioned name why we are not writing di before ethyl. Dimethyl is written after ethyl, although D comes first in the alphabetical order, but E comes later on. Do remember, you have to check the position of ethyl group in this compound, and you can see that we have violated this rule of alphabetical order. Because do remember the term di, tri, tetra, secondary, tertiary, these are usually ignored while writing the substituents in the alphabetical order. We have to consider methyl because M comes later on in the alphabetical order as compared to E, so that's why this is written later on. D is not considered in the alphabetical order. Iso, neo and cyclo cannot be ignored. These has to be mentioned in the alphabetical order. Next rule is rule number 6. While numbering, if you get the same number for one of the substituents in both the directions, then we have to choose the direction in which one of the remaining substituent gets the lower number. Again, I am referring to the previous example that we have seen just now. This carbon chain is having 7 carbon atoms, and at position number 2 and 6 there are 2 methyl groups, and whether we number it from this side or from that side, in both of the cases methyl groups are going to get number 2 and 6. So what we have to do now, which numbering is to be followed? Now we have to see the other substituent. If one of the substituent is getting same number from both of the sides, then see the other point of difference or the other substituent. The other substituent, that is ethyl group, is getting number 3 if we number it from this side, and it is getting number 5 if we number it from this side. 5 is a higher number, so we don't have to choose this numbering system. We will have to choose the chain in which ethyl group is getting the lower number. So the correct name of the compound is 3-ethyl-2,6-dimethyl heptane. The last rule of IUPAC nomenclature is, upon numbering, if a compound gets the same set of numbers, then we will have to prefer the direction in which alphabetically preferred substituent is getting the lower number. For example, consider this compound. It is a 7 carbon chain having 2 substituents, that is methyl and ethyl. In this numbering, if we follow the numbering from this side, these are getting position number 3 and 5. And if we follow the numbering in the opposite direction, we can see that again we are getting the same numbers, that is 3 and 5. Substituents are attached at position number 3 and position number 5 in both of the cases. So which numbering should be followed? We are going to follow the numbering in which alphabetically preferred substituent, that is among ethyl and methyl, ethyl comes first, so alphabetically it comes first. So this numbering will be followed in which alphabetically preferred substituent is getting the lower number. So the correct name of the compound will be 3-ethyl-5-methyl heptane. In examination, if you are following the opposite or the otherwise numbering and you are writing the name as 5-ethyl-3-methyl heptane, it will be considered wrong. After knowing these rules of nomenclature, you should be able to write the name of the compound. How you have to write the name? We have understood all of the rules. We have got to know that which numbering should be followed, how substituents should be numbered. Now assembling the name, how you have to assemble the name and how you have to write it. There is a systematic system for writing the name as well. In this, you have to first of all mention the position of alkyl groups on the parent chain, and position of alkyl groups is usually written in the numbers, and then you have to name the alkyl group, and then in the end you have to write the parent hydrocarbon. For example, consider this compound. In this compound we are having ethyl group attached at position number 6, and in this numbering scheme ethyl group is attached at position number 4. So of course we are going to follow this numbering scheme. So the correct name of this compound will be 4. First of all, mention the number at which substituent is attached. Substituent is attached at position number 4, so it is 4. And the name of the alkyl group is ethyl, and in the end we are going to write the parent hydrocarbon name, which is nonane. Name of the alkyl groups, they are usually separated by the hyphen. When 2 or more like groups are present or same groups are present, their numbers are indicated by the prefixes di, tri, tetra, etc. Their numbers are grouped together and these are usually separated by commas. If two identical groups appear at the same carbon atom, the number is separated twice and this is usually separated by the commas as well. For example, you can see this compound, it is a 5-carbon chain. At position 2 there are 2 methyl group, so you are not going to write it as 2-dimethyl. You will have to write 2,2. Position of both of the alkyl groups are to be mentioned, whether it is on the same position or at the different position. If it is on the same position, even then write 2, 2 and you have to put a comma in between these two digits. Then you have to put a hyphen and then write the name of the substituent, which is dimethyl, and then you have to write the name of the parent hydrocarbon, which is pentane. So these are some important rules for nomenclature of alkanes, and you have got to know how to write the name of alkane as well. Girls, do remember IUPAC nomenclature is so systematic that neither two compounds get the same name nor one name can be assigned to two different compounds. IUPAC system gives a unique, specific and different name to each and every compound that exists on this universe. It's not possible that two compounds which are different from each other, they get the same name. It is not possible at all. Girls, after knowing the nomenclature of alkanes, now you should be able to draw the line diagrams of alkanes as well. Now, do remember there are 3 types of diagrams or structural representation of an alkane. It can be a structural diagram which will contain all of the carbon atoms and hydrogen atoms and their linkages are shown as well. Single line is telling you or showing you the single bond. It can be a condensed diagram. In condensed diagram, usually we write CH3, CH2. The terminal carbons are written as CH3. The middle carbon atoms are written as CH2, CH2. There is no line in between. It is understood that they are bonded by a single bond. And again, terminal carbon is shown by CH3. There is another form which is called line diagram. This is the most modern one and it is being followed these days as well. It will save a lot of your time and a lot of space as well. Line diagram is usually drawn in the form of lines. There are various crust and trough and these zigzag lines will show you the structure of compound. Do remember, each end is a CH3 group and each vertex or the elevated portion is a CH2 group which is present in between, and the terminal end is always showing CH3 group, as it can be shown over here as well. If you want to draw a line diagram of a compound which is having 6 carbon atoms in it, you can start drawing in this way or you can start from the top as well, doesn't matter. This is carbon number 1, this is carbon 2, carbon 3, then comes carbon 4, 5 and 6. So this is a hexane that you have drawn. Every end or point on a line diagram will represent a carbon atom. Hydrogen atoms are usually not shown. It is understood the terminal ends will have 3 hydrogens and the middle carbon atoms will have 2 hydrogens in it. Each end is a CH3 group and each vertex is a CH2 group. Line diagram of various compounds or alkanes is being shown to you people along with their condensed formulas as well. You can see, do remember, for methane there is no line drawing because there is 1 carbon, so you can't draw it, you can't draw a line for that. It starts with ethane always and it is just 1 line and it is always a slanting line. Each end is representing a CH3 group, this one and this one as well. C3H8 or propane can be written in this way, and this is CH3, then CH2, CH3. Butane can be written as CH3, CH2, CH2, again CH3. Then pentane can be written as CH3, CH2, CH2, CH2 and CH3. Do remember, both of the ends are having CH3 groups and middle ones are always having CH2 group in it, right? Similarly, you can draw hexane as well in this way: CH3, CH2, 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 CH3. Then you can have heptane, octane, nonane and decane drawn here as well. Branching can also be shown in the line diagram. For example, this is a normal heptane having 1, 2, 3, 4, 5, 6 and 7 carbon atoms. This is a compound that is methyl butane, 1, 2, 3, 4 and there are 4 carbon atoms in the chain. And branching, this is being shown over here. This is a methyl group which is attached to butane, methyl group. Only single straight line is showing you CH3 group at the top. Then ethyl group is shown usually in this way, straight line and then a slanting line. This represents CH3 and this end represents CH2, which is linked with the parent chain, that is hexane. Similarly, propyl group can be shown in this way: CH3, CH2, CH2, which is attached with the parent chain, and this parent chain is a nonane. Similarly, two attachments can also be shown over here in this way. One of the linkage is being shown over here and another linkage is being shown over here. 2,6-dimethyl octane. This straight chain is a octane having 1, 2, 3, 4, 5, 6, 7 and 8 carbon atoms, and numbering will start from this point so that this substituent, first substituent, is getting the lowest number, that is 2. So 1, 2, 3, 4, 5, 6, 7 and 8. Now this is an activity or homework for you people. You have to draw the line diagram for each of the following alkanes that are being mentioned over here. How you have to write the line diagram? For that, you have to first of all write the structural formula. And how can you write the structural formula? From the name, we will have to move in the backward direction. You have to first of all see the parent chain. Parent name is pentane, so draw 5 carbon chain and number it as 1, 2, 3, 4 and 5. And it is a trimethyl, means there are 3 methyl groups attached and the positions are being mentioned. These are 3, 3 and 2. 2 methyl groups are attached at position 3 and 1 methyl group is attached at position number 2. So this is how you have to write first of all the structural diagram, and then from that you can easily draw the line diagram. These are 5 questions only and you have to draw the line diagram for all of them. Answers will be given to you tomorrow, inshallah. Not tomorrow, in fact in the next lecture. Girls, this is the activity which is given in your books at the end of this IUPAC nomenclature, and it is at page number 124 in my book. This activity contains few questions. This is again your homework and answers will be given to you in the next lecture. First of all, you have to do it by yourself and you can ask me questions if you have any queries or you are unable to solve any of these. You can ask me questions later on the WhatsApp group as well. Name each of the following compounds according to IUPAC system. You have learned about IUPAC rules, so you will have to name all these compounds systematically. Second question is, indicate what is wrong with each of the following names. Give correct IUPAC name if possible. How would you get to know that? First of all, draw this structure the way I have told you just now. Draw the structure propane. On position number 2 attach 2 methyl groups. Can you do that? If you can do that, it's okay. If you can't do that, means this name is incorrect. So what is the correct name? You have to write it as well. Third question is, write the structures of the following compounds. This is your home assignment as well and you have to do it by yourself. This is all for today, girls. You have to practice nomenclature at your home as well, and as you know, practice makes man perfect, so it is all the practice that is required. make a separate copy of nomenclature at your homes and write all of the examples, all of the questions, solve all questions on that copy and keep it safe with you. It will help you a lot in the end. Thank you very much. Have a good day. Allah Hafiz.